All right. So yesterday you all started on SQL, and so far it sounds like everyone is having a pretty good time with it because what was it last week? We were doing oh oh right, we were doing a lot of the web stuff still last week. And now we're focusing on databases. And so far you've covered select statements and operators, along with where conditions. We're going to continue to use some of these where conditions today. We'll throw one different one at you, and we'll also integrate some aggregate functions in some of our queries as well. So all of this repetition should help continue to drill in the SQL commands for you. And, and today we are, like I mentioned, covering group by and inner joins. So when you have a large collection of, actually, before I start with this, has anyone had any trouble with Docker and SQL, or has that been pretty straightforward for everyone too?
Think we were able to get it to work for the most part. I do have, I guess, questions about like when we were using it yesterday, the cars database,
Hmm.
um, making sure that we're also able to use it in like the next days. So if like
Hmm.
if we pulled like did a pull request from GitHub, we have each days, right?
Hmm.
But
Yes.
being able to actually use that database and other files.
Right.
That makes sense if I'm
Yeah,
saying
no,
that correctly.
totally, totally. So let's look at the cars database and let's look at these commands. So by default, we use this long command here, and we have this option just so as you're going through the database over and over, we're not just like flooding your computer with images every day. This option means remove. So basically, as soon as you exit the container, it is going to self-destruct. It's going to destroy itself. It's going to disappear into the ether. And if you omit this option, then every single time you start a container, you will have it will not self-destruct when you exit out of it. And then you'll be able to run commands like docker ps, and you'll be able to see that these containers are persisting. Now, one thing I'm not so sure about is have you run into that yet where you'd be, I don't know, doing some changes to the database and then the next day those changes are gone? Have you actually been experiencing that?
I don't think we've done any changes to the database.
Okay. There shouldn't be a need to there shouldn't be a need to necessarily omit the remove because the Docker volume should store the changes that you make to the database. But we can try this out. And if we see that changes are um, being reset, then this is what you should do. You just omit this option here. And so every time you go to run the container, then you'll be running it from the container that's already been built, as opposed to building a new container from the image. Does that make sense?
Yes.
Okay, cool. So I do already have these two containers running. Um, we'll just jump in, and if you need me to run through the initial setup again, I could do that too. Okay, so maybe it'll actually be easier to have this in the VS Code terminal. So let's just run through this real quick, and then I'll switch to having this open inside of my VS Code. So we're going to be covering group by along with joins, and there's nothing really too tricky here. We're only going to be covering inner joins today. I actually glanced at tomorrow's lesson and the day after. I don't know if we're going to be throwing other types of joins at you, but we'll definitely cover that when we cross that bridge. Okay, for now, let's get this curriculum up in VS Code. Okay, all right, so I've got my cars database running. And if we do account a select command just like you all learned yesterday, we'll be able to, again, use aggregate functions to modify our query, right? Because if we just do a select of everything inside of car model, then we get all of the columns inside of that. So now let's try this. Oh, by the way, I'm hitting Q. If you have this colon here and you have a lot of things to scroll through, instead of scrolling all the way to the end, you could just hit Q to exit out. And now let's change this command from using a wildcard, which will select everything, to first using this aggregate count function. And then we want to pass in this distinct keyword to be extra safe. So distinct will prevent the repetition of like similar entries. Let's say this is useful, for example, if you had a database of, I don't know, different desserts, and there are different types for these different desserts. Um, there's going to be more than one dessert for each type, but the information you're looking for is how many types there are. So that's where distinct would come in handy. Now let's run this. And this allows us to see that we have 99 rows inside of this table. And if we want to be a little more specific, let's say we want the count specifically of a particular make, or for each make, actually, we can, instead of using distinct model, use that wildcard again. So now we're going to be getting the count of everything from car model. But that alone isn't really going to give us what we want, right? We want a count of every model. And so this is where a group by clause comes in handy. And so if I group, if I can type, if I type group by make, I need a space and not an underscore. Now we see the count for every make. But this is still not really so useful because this doesn't tell us for what makes these counts belong to, right? So we got to do a little more tweaking to our query to make this actually useful for us. And what we can do now is, let's see, we're going to add another column to retrieve from. So in addition to selecting the count, we're going to select the make as well. So you could use comma as a delimiter to select multiple columns or even aggregate values, right? And as long as they are separated after the select and before your next clause, it will allow you to run the query. Okay. that. And if we were to try to run this, oh no, we're not there yet. Let's try running this. This allows us to order the results. And here we are ordering by count. So we have the highest number of results at the very top because we've selected a descending order. Now, by default, if we don't pass in this descend option, order by will order by ascending order. So now we have the lowest count and then results climbing up from there. Okay. And something else that this mentions is if your query starts to get too long, SQL doesn't really care about white spaces and new lines. So you saw earlier as well, I think, if I were to hit enter here, or I guess I can't do a soft enter unless let me try a command. If I were to run this, for example, we have our clauses on different lines. It will still work. And this is especially handy if you are writing out your SQL scripts because it makes it a lot more legible, easy to read, easy to edit, and it's just neater. So that's something to keep in mind when you're writing SQL scripts. If you're in the terminal itself running commands, doing it all on a single line is fine too. Okay. So now, if we wanted to filter by group by, and we want to filter based on select makes. So like in this example, we want only Volvos, Fords, and Kias. If we were to try this, it's going to throw an error at us. It doesn't like that we're having our where clause after the group by. So one thing we can do is instead of using where, use the have clause instead, or having, not have. And now we can see that we have the results we wanted. It's no longer complaining. Now, that's not the only thing you can do, right? You could also just reorder your clauses. If you, I don't know, just prefer where over having, um, then we could just get rid of this group by make, or not really get rid of, but move it, right? So instead of having group by make here, we're going to select from our car model where the results are going to be inside of this list. And now if we pass in group by, we get the same results. So just like in programming, there's more ways than one to accomplish whatever goals you are trying to accomplish. And how you go about writing your queries is up to you and depend on your use case. Okay. All right, we're going to talk about joins. Let me see if I could find this in my browser real quick because I've got an image that I want to show you. Oh, I might have closed out of it. I don't know why this isn't in the lesson anymore. I could have sworn it was before, but if we were to search for SQL joins, we could see that there are actually multiple types of joins, right? And I don't know if you've seen images like this before, but these Venn diagrams basically help chart the differences between certain joins, right? What we're going to be working with today specifically is the inner join. And if we were to exclude that keyword, we would still get the same results because the inner join is the default join. So it is mentioning left and right and full joins, and we'll demo what that looks like in a sec. But let's rewind a bit and let's just start off with inner joins. So here, if we want results that exist in both the app user and advertisement table, because we see we have all of these different tables and we want to see if there's any commonality shared between them, right? Between advertisement and app user. We could use an inner join following our from clause. So select from, all from app user. And we'll use an inner join to basically join another table advertisement. And we're going to use this keyword on to basically say, to point to where we are looking for that commonality, right? So in this case, we want to find where there is a user inside of app user whose account ID matches the seller account ID in the advertisements table. So on app user dot account underscore ID equals advertisements seller account ID. And then let's limit that to 5. And you always need to use a semicolon to end your query.
Got
Help
the 5.
less than 5. Okay. So now we see we have all of these results. All of these users are both, they exist in both tables. Um, Delmy, Carl, Stephen, Aileen. I don't know why the README today is using a name that, well, we'll get to that later, I guess, that wasn't showing up in this list because, yeah, it looks like those are the results we should be getting, just these 5 names. Now, let's see. We want to, if you want to look at this command a bit more closely, we are basically selecting every column because we're using a wildcard and we're grabbing it from the app user table primarily, but we're also joining results from the advertisement table and we are pointing to an inequality between the two at the account ID for the app user table and the seller account ID for the advertisement table. And if we were to, again, run this without the join, or sorry, the inner keyword, we see that we still get the same results because again, uh, it will default to an inner join. Okay. So now this is where I think things start to deviate because I don't, when I was running through this before, I wasn't getting anything for Janny. And then if we, even if we change the spelling, because I think the spelling is different, it's not going to turn up a result because Janny is not inside of both tables. If we search these tables individually, we'll be able to see Janny in one, but not the other. So let's do select all app user where app user dot first name equals Jenny. Delete this and with this. And so we see her inside of our app user table. Now, if we were to search inside of advertisements, and there is a different value that we're looking for now, right? Because both tables have different columns. What we're looking for is, let's do the account ID, except in this table, again, it's going to be called the seller account ID. And if we do this here, well, first off, we could see her account ID here, right? If we were to just pass that in as is, it's going to, oh, I was hoping it would throw an error. It's going to return nothing because she's not in this table. And so let's try this again with somebody else. Let's go back to our command where we select um, users from both tables using our inner join. And, oh, this is where I was missing the limit. If we see these 5 results, because we've set a limit to 5, let's just grab one of them. Let's use Carl as our new example. Now, if we go back to running our select with an inner join between the two using Carl, and Carl's last name was, I already, oh, it's in here. It should be in here. Slanowski. We get results. And if we were to search these tables individually, let's see, what is Carl's ID? Carl's ID is 55. We confirm that he is inside of the app user table. And then let's confirm that he's inside of the advertisement table as well. And he is. Oh, let me actually run a different command because I was running both on advertisement. So let me delete that. We type Carl here. And now we see that he's inside of the app user table. Okay. What else can we look at? This final example gets the number of doors for every make and model. So let's do a select. I'm going to select, instead of selecting everything, we're going to ask specifically for a make from the car model table. And we're going to also look for the model and look for the number of doors. We specify we want this from the car table, but we also want to join from car model. And what these two tables have in common should be the car model ID.
So in all these different tables, they need something that joins them all together, right? In order for this join to be to be used like this to get specific data from different tables. So they all need the ID of the same number.
Exactly, yes. If you've looked ahead in the lesson, that's going to be covered either tomorrow or the day after. So let's just glance at that real quick to give you some exposure. Okay, yeah, yeah, there's an image right here that shows example of like these different tables, right? And this is how they're connected. We have the account ID and user profile matching the account ID in app user, and then so on and so forth. So on Thursday, when you start to talk about schema design, I believe you're going to be using um, a design tool that helps you mock out these schemas. And forget which one quick database diagrams. If I go to try the app, this is what that looks like. When you're specifying details inside of your schemas, so customer, for example, looks like it's got a matching ID with customer ID and customer orders. The syntax here is we use this kind of a funky forward caret arrow to say that we want a foreign key value for customer ID using the oh I mean for custom orders, we want to use the customer ID from the customer profile table or the customer table itself as the linking point, the connection between cust orders and the customer. So if the customer has an order, it should have a customer ID in cust orders, and we will be able to identify all of that customer's orders that way. Does that make sense?
Yes.
Cool. Yeah, let's not spend too much time on foreign keys and all this stuff because we're not there yet. Um, we are, I think right now, just running a few more examples on inner joins. Actually, let me show you. If we go back to the example with Janny and we change our query, we're going to try a different join instead of an inner join. And okay, so this was the inner join. And we see that it pulls no results because we've already confirmed that she is not inside of advertisements, right? So if we switch this to a left join, we actually pull the result because what left join is saying is we want to find results that not so much is in both tables, but exists um, either in both tables or only in the left table, that first table that we selected. Now, if we do a right join, y'all can probably guess what's going to happen. We don't get results because she's not inside of the advertisement table. And if we go back to that Venn diagram image, images like these are pretty handy in remembering how these various joins work. So here, when we are using a left join between table A and table B, we're trying to match for this key value that's shared by both, right? And it's going to capture everything that's inside of A. Now, that might seem kind of useless because why wouldn't we just search table A, right? You can use the same syntax to filter. So let's say we wanted users in table A that do not exist in table B. Now we could still use the left join, but we also want to specify when we specify where we want to match and point to that the key in the right table is null. I don't know if y'all could read that. This text is like super small, but let's try this with Carl because with Carl, we saw that he was in both tables, right? So if we grab Carl again, we have our app user, inner join, advertisements, blah, blah, blah. Now let's do a left join. We'll see that we're still pulling it up. And if we do a right join, of course, we're going to see that he's there as well. But now with this syntax, we can exclude certain results, right? So let's say we want folks that are only in the left table, but not in the right. What do? We do this exact same thing, but we add another clause where where first name is Carl, last name is Klanowski, and um, advertisements seller account ID is null. And now we get nothing because he does exist in the second table and that disqualifies him from our query. I don't know if we'll be diving into left and right joins too much. It can definitely get handy once you're actually writing your own applications in APIs inside of Django and playing around with your own databases. But if you need any kind of refresher at any time for how various joins work, these Venn diagrams are usually very helpful and very easy to find. Like you just do an image search for P-SQL joins, and this is like the first thing that comes up. Okay. Now there are a few more examples. I don't think any of it is throwing anything too complicated though. Let's switch to, for example, I think we ran this one, right? What's happening here is we're selecting, right, the we're looking for specific makes, our number of doors per make per model from two different tables using a join. And we're matching the model ID in between. And this gives us these results. And it shows us for every make and model how many doors there are. Now, if we wanted to, I guess, get the distinct street name of anyone in New Orleans who placed an ad in May of 2024, we could use multiple joins again to combine data from multiple tables. So join isn't specifically just for one or for two tables, I should say. You can do select distinct, street name, user profile P. And this is an alias. I don't know if that's been covered yet, but whenever you specify where or from the or which table, I should say, that you're trying to look at, you can attach an alias to it. And by attaching an alias, you can kind of save yourself some effort, I guess, typing. So here we're also going to give an alias to app user. I just kind of habitually started using soft return to do multi-lines now. And to use that alias, we just prepend it to the column name that we're looking for. So from app user, we want to look for account ID. A represents app user. So if we do a.account ID, that's going to be app user.account ID. And we want to match that count ID between these two tables. Now, we did want to join another table because we're looking for users that placed advertisements in a particular month. So we do another join. We give this an alias as well. Let's just say AD. And we already remember from earlier, it's the seller account ID that is shared by these two. Or another way of putting it is used as a foreign key by the by these tables. Let's see, ID, and now we want to specify which city, and we let's run this as is actually. We get these two results. Now, if we wanted to be a little more specific and incorporate month into this, right? We've already written this really long query where we've used the where clause to specify the city. We could add to that using extract and extract. So from these results, basically from this subset of results, we want to grab the results that have an advertising date for a month matching this value. So month of May is going to be represented by 5. Advertisement date. Oh, advertisement date. And that filters out for Hamilton Street. Okay. And there's a link inside of the README that has an overview of, whoops, that's not what I want. I want to click on, yeah, that has an example of various functions to reference. So if you are in the habit of using cheat sheets, just go ahead and start throwing some of these commands into your cheat sheets. Okay. That is pretty much it. Yes, it does actually talk about aliases. So as we see here, if we remove these aliases, it's going to work exactly the same. It's a convenience tool, but it's definitely handy when you're writing longer and longer queries. Okay. Today's challenge is SQL queries 2, and then SQL Zoo is, I think, an external challenge. You'll have these to run through. But your goal for today is to write queries that will match these objectives. And as usual, make a PR when you have that completed. Okay. I will open up breakout rooms. Y'all can take a break, and we'll meet back here at, let's say, 9:15.